So last time I started introducing to you algebraic or analytic technique of determining limits. No? So guided by some theorems and other principles that will enable us to evaluate limits without having the graph or having table of values coming from the left, coming from the right. So by just looking at the function, we can determine the limit of that if we're going to use the theorems appropriate together with some principles that I had with you. Okay, guys? So we're going to discuss first limits of functions having no problem as x approaches a, meaning the function has at least an interval, open interval containing a, where x is approaching, and that um, function on that interval from the point I can go to its immediate left and its immediate right. Okay, and I already explained to you what we mean by that. No, although it is best explained when we go to continuity. So we are going to have first limits of functions where the limit of f of x as x approaches a is equal to the function itself, value of the function at a. So, okay? So, limits of functions so we're going to have the first case. The first case we have limit of f of x as x approaches a is equal to the function value at a. But of course, not all, no? So you can do this if you have a polynomial function, a rational function, where a is in the domain of f, where if f is a rational function, or a polynomial function. Or even other functions as long as satisfied yung there is an open interval containing a, and from a, which is in the domain of the function, that a, and I can go to its immediate left and immediate right. So for instance, if I have a square root of x, guys, and if I am interested sa value ng x near 0, can I go to immediate right? Yes. Can I go to its immediate left? No. Why is it that there is no immediate left in the curve, in the graph of square root of x? No? Because if you're going to graph that y equals square root of x, it is from this point up to yan, to this, no? So if this is the point where I am interested, I can go to immediate right, but I cannot go to its immediate left. Why, guys? Because there is no graph to the left, no? That's why if you're asked of the limit here, the limit as x approaches 0 does not exist. But if you're interested only to the limit as x approaches 0 from the right, it is equal to 0. From the left, does not exist. Therefore, the two-sided limit does not exist. Only one-sided limit, which is from the right, is the one that is a real number, no? for the limit. Is that clear, guys? So this is an example of value of x na wala siyang immediate left. Although ang a or yung x equals 0 is in the domain, but there is no immediate left. Is that clear, children? Guys?
Yes,
So, madaling mag-evaluate ng limit kapag ang limit of f of x as x approaches a is just equal to the function value. So, for instance, if I have this limit, let's say we are asked to evaluate number 1, if I have limit as x approaches 2 of x squared minus 2x plus 1. So since this is a polynomial, so I can apply direct substitution rule. Is that clear, guys? So meaning I'll just find the function value at x equals a. Is that clear, guys? So even if you don't do it individually, you don't get any more the individual limits showing that. Okay, so you can go directly. So we have 2 squared minus 2 times 2 plus 1. By the way, if there are still variables, you cannot remove the limit, operator. So limit is just, it's like an operator that you have to do, you're going to do something, no? So if you're going to simplify this is equal to 1. Okay, guys? Yan. Number 2, if I have limit as x approaches, let's say, -2 of 4x minus 1 all over, we have 2x squared. So that is 2 times plus 1. What about this one, guys? So is -2 in the domain of this rational function, guys? Guys, where is our officer? Is our
Hello po?
You can call a name if you want. Is -2 in the domain of this rational function?
I'm going to call Kyle Tan po. Kyle Tan.
Is -2 in the domain of this rational function? Guys? It's yes, no? Guys? Do not chat in the chat box because I don't see your answers. Because I don't see
He said
the chat
yes po.
So it's in the domain. So since it's in the domain, so we have already a theorem for that. So I can go to its immediate left and immediate right. So I can apply direct substitution rule. So even if I will not use limit of the numerator and limit of the denominator, so I can go directly, no? But if you want to go to a detail of the solution, you can do that, of course, okay? So we now have what? So 4 times -2 plus 1 all over 2 times -2 quantity squared plus 1. And this is equal to, it is minus. It is -1 in the numerator. So it is -9 over 2 times 4. That is 8 plus 1, 9. Am I correct, guys? Guys, so what's the limit? -1, okay? Okay, number 3. If I have limit as x approaches, for instance, 3 of square root of, although this is not rational, it is a radical. So, but let's see if we can apply direct substitution here. For x plus 1. If x is, let's say, let's try, if x is substituted to x, will it be at the end point of the graph? What do you think? Will it make the radicand 0? Because if the radicand will be 0, the radicand, the value when x is 3, it is at the end point, okay? For this case, because this is actually part of a parabola. Since if I substitute for here, so it's not 0, therefore, guaranteed that I can go to the left and right, immediate left and immediate right of 3, okay? So there is an open interval containing 3 that I can go at least, however small that distance that I can travel from 3 going to its immediate left and immediate right. So there is an open interval containing that. So I can apply substitution technique. So we now have a square root of 3 times 4. So that is 4 times 3 plus 1. Or what's the answer, guys? Square root of?
Square root of 13 po.
13. Okay? So that's the limit. Number 4, if I have limit as x approaches, say, pi, and then I have sine of x, and then plus cosine of x all over 1 plus 2 cosine of x. What about this? So this is trigonometric. So, and we know that sine and cosine, based on your experience in trigonometry, the graphs are what? Have no problem, no? So meaning the graphs continues to the left and to the right, no? For both sine and cosine. And if I substitute x to pi to x here, cosine is what? -1 times 2. So guaranteed it will not make the denominator 0. Okay? So, and this is what? This is rational function in what? It takes the rational function form, but it's not really rational function, no? But we can treat it like that, okay? So, but technically it's not a rational function. So x equals, pi is in the domain, and I can go to its immediate left and immediate right for the graph of this, guaranteed, no? So that there is an open interval containing pi that I can go to its immediate left and immediate right. So we now have sine of pi plus cosine of what? Of pi all over 1 plus 2 cosine of pi. But what is cosine? What is sine pi, guys? 0. Cosine
0 po.
pi, -1.
-1 po.
And then here, 1 plus 2 times
-1.
-1. What's the answer? Is it 1?
1 po.
Okay, so that's the limit. Okay? So take note when the time you have to remove the symbol limit. So if there is still a variable, you cannot remove the limit. Okay, guys? Yeah. But there are functions undefined when x equals a, but limit possible to what? To exist, no? So let's have now the other case. The other case this time are those functions na ang limit ay what? Nag-exist pero ang numerator at denominator niya, ang limit ng numerator, limit ng denominator, although nag-exist parehas pero nag-i-equal pareho sa 0. So okay, ang tawag doon indeterminate. Anong tawag doon, guys?
Indeterminate.
Were I able to discuss to you indeterminate already last time? The indeterminate 0 over 0?
Yes po.
Okay. So this case this time, so letter B, we have limits of f of x ng quotient, no? Over g of x as x approaches, let's say, a, takes the indeterminate form, takes the indeterminate form what indeterminate form, guys? 0 over 0. But actually, this is not the only indeterminate form, no? But this is the simplest indeterminate form. Okay? So, number 1, let's say we're asked to evaluate. Yan. This limit as x approaches 1 of x squared minus 1 all over x minus 1. So let's check if you're given a quotient, always, you have to be careful always, no? So always check if the limit of the denominator is not 0. If it is not 0, then, and the limit of the numerator is, let's say, a real number, so you can proceed immediately and apply direct substitution rule. But if the limit of the denominator is 0, you cannot apply direct substitution rule, and you cannot split immediately this into quotient of limits. Is that clear, guys? So you're not supposed to have it limit of the numerator over limit of the denominator. But to check if it is indeterminate form, you have to solve separately. You check the limit of the numerator and the limit of the denominator. Start lagi kayo sa denominator. Kasi pag ang denominator hindi nag-0, so you can proceed immediately kung nag-exist naman ang limit ng numerator. So, kailangan wag mag-0 to. Nag-0 ba ang numerator? I mean, ang denominator, ang limit? Yes. So, possible na maging indeterminate siya, no? What about limit of the numerator? Dahil polynomial to, I can apply direct substitution rule here. So, this is 1 minus 1. And what's the limit? 0. Hence, this limit takes the indeterminate form, what? Anong indeterminate form, guys?
0, 0 po.
0 over 0. I mean, IF indeterminate form, ha? So 0 over 0. Do not equate this to 0 over 0, ha? Okay, guys? That's wrong. You don't equate this to 0 over 0. So you violate transitivity in algebra. Because if you say that this is equal to 0 over 0 and later, you will be able to get a value, so you are violating algebra. Di ba sabi sa algebra, if A is equal to B and B is equal to C, then A is equal to C. So, ibig sabihin mo, kung ang itong limit na to ay equal dito at itong limit na to equal pa rin sa isang number, so para bang sinasabi mo na ang 0 over 0 equal to that number. Okay, guys? So, instead, dito mo na lang lagay. Lagyan mo lang ng semicolon, lagay mo here 0 over 0. Sa guide. You can do it mentally. Pwede namang wag nang ipakita ito, ha? So, pwedeng i-mental yan. Dito ganyan lang yung arrow. Lagyan nyo ng arrow here. Halimbawa, this going to be 0. This is going to be 0. And then you write here 0 over 0. Is that clear, guys? Yan. You can do that. Para mas mabilis, na? You don't need to do the details like this. So, therefore, we say that the limit as x approaches 1 of x squared minus 1 all over x minus 1 equals. Kailangan matanggal natin yung factor na nagsi-0 sa denominator kung maaring matanggal. Okay, guys? So, ang gagamitin nating principle, di ba sabi, kapag daw ang limit ng g of x ay equal sa limit ng ay ang f of x ay equal lagi sa g of x except at x equals a. At there is an open interval na kung saan they are equal. At least there is an open interval containing a that f of x is always equal to g of x except at x equals a. Then, ang gagawin natin, hanapin natin yung what? At yung ang limit halimbawa ng g of x nag-exist, so equal din ang limit nun sa original na to. So hahanap tayo ng function na equal ang lahat lagi ng value niya dito sa x squared minus 1 so on some open interval containing x equals 1. Is that clear? Undefined dito pero defined dapat yung what? Yung g of x doon, no? Yan. Okay? Okay, ang limit ng g of x nag-exist sa x equals 1. So let's see. So we now have, pwede natin i-factor to into x plus 1, x minus 1. All over x minus 1. As x approaches what? 1. Okay? Yan. For this case, hindi natin pwede siyang guys, hindi natin siya pwedeng limit ng numerator over limit ng denominator You cannot split that into quotient of limits. Kasi nag-zero ang denominator, no? Ang limit niya. So we cancel this. So we are allowed to cancel that because hindi naman equal ang x sa 1 kundi approaching only. So this is now equal to guys to limit of what? Limit of x plus 1. Ito mas madali nang kunan ng limit. Yan. Kasi linear function lang yan. So anong limit? Dahil polynomial ang linear function, ang linear, so we now have 1 plus 1 and that is equal to 2. Okay guys? May question ba rito guys? Guys?
None po for me.
Limit as x approaches, let's say 2. Ano naman ang technique kapag may radical? Pag may radical, ang technique naman is what? So we have, let's say, x minus 1 and then minus 1 all over x minus 2. Let's see. What's the limit of the denominator, guys? Hindi ko na isa-isahin like in number 1. Pwede nang i-do it mentally. 2 minus 2. So the limit of this therefore is what? 0, no? Am I correct, guys? Anong limit ng denominator? Ay numerator?
0 din po.
2 minus 1. That is 1. So dahil hindi naman ito, what you call this? Hindi naman nag-0 ang ilalim. So guaranteed tayo na kapag nilagay ko ang 2 rito sa x, ang square root niyan ay 1, no? So meaning, I can go to immediate left and immediate right ng 2 dito sa radical na to. Pag ito'y 2, so meron pang espasyo, parang may space pa, that I can move to the left and to the right na hindi ko maaabot yung what? Yung x na equal sa 1. Kasi bawal na yan sa 1, di ba? I mean, hanggang 1 yan, dulo yan eh. Ito yung dulo niya, right? Ito yung 2 halimbawa. Am I correct, guys? Di ba kapag 1 to 0 na to, dulo na yan. So, ibig sabihin, going to the left nitong 1, undefined na yung function. So, from here, I cannot go anymore to its immediate left. Pero kung nasa 2 ako, meron pang open interval. Pwedeng narito, mas maliit pa, na makakapunta ako to its immediate left and immediate right. So, it means I can do the substitution rule here. So 2 minus 1, 1 square root is 1 minus 1. So the limit is 0. So this has the form 0 over 0. Hindi equal yan Dito, it has that form. So that is the form of that limit only. That it means that limit may or may not exist, no? So let's see. So ang technique naman, if that is the case, guys, anong technique? Have you search for that when you were given an assignment? Nakita niyo ba yan? Guys, na assignment in advance. Pag ang assignment ay hindi ko pa na-discuss, incentives ko yung nilalagay yon. Kasi nga, hindi pa natin na-discuss. So that it will not affect the denominator. But it will increase your numerator kung masasagutan ng tama. Okay, guys? So, the technique, guys, is to rationalize the numerator. Okay? At kailangan matanggal natin itong x minus 2. Makaproduce tayo in the numerator ng factor na x minus 2 so that we can cancel. O, let's multiply. So, paano mara-rationalize, guys, ang numerator? Meaning matatanggal ang radical. We're going to multiply by what, guys? Guys?
Pwede ba conjugate, sir?
Numerator and denominator by its conjugate na. So, ano ang conjugate niya?
Square root of x minus 1 plus 1 po.
So, it's square root ng x minus 1 plus 1, no? So, same thing sa denominator, no? We multiply by square root of x minus 1 plus 1. Okay? And giving, ano nang mangyayari, guys? Limit. Yan. Magtatanggalin mo na yung word na limit, ha? So, we now have, saan ba mas maraming isusulat na expression? Saan bulk ang expression? Sa denominator o sa numerator?
Denominator.
Denominator, no? So we have x minus, doon kayo magsimula para maganda yung fraction nyo. Kailangan marunong. Nung ako nanonood ng Korean telenovela, sa mat nila may class sila. Doon sila nagsusulat sa kung saan mas maraming sinusulat para gumit na yung fraction. A minus B, A plus B form. What's the product? Square the first. So x minus 1 minus square of the second. So minus 1. No, minus 1. So, and this is what? Saan na-equal yan, guys?
X minus 2 po.
X minus 2. So I can now cancel that, right?
Yes
So I
po.
can cancel that. So I can now cancel this with this, na? Medyo gawin ko lang siyang manipis. Yan. I can cancel it with this. So, what is now left? So, ang natira na lang, mas simple na function, no? Pero ang limit niya para sa limit ng original. Okay? So, as x approaches 2, no? So, the denominator now becomes simply square root of x minus 1 plus 1. In the numerator, simply 1. Okay, now can I now get the limit? Nagsisiro ba ang limit ng denominator?
Hindi po.
Hindi na. So we can now apply direct substitution rule. Na-verify na naman natin kanina na ito pwedeng gamitan ng substitution rule, no? Itong radical na to. Kasi hindi naman siya dulo. Meron itong tung na to, may left and right siya, immediate left and immediate right. So I can apply substitution technique. So 2 minus 1 plus 1 in the denominator, 1 here. So this gives us what? Anong value?
1/2 po.
1/2. Okay?
Pwede na sir, diretso po na 1/2.
Pwede na kasi a numerical number na naman yan, di ba?
Okay po.
Pwede nyo lang i-mental. Ito. Kung gusto nyo, 1 over 1 plus 1. Kasi number na to eh. Hindi na to limit. This is now answer to the limit. I mean, we are not anymore performing limit. Kundi answer na yan sa limit. We are now trying to simplify this value ng limit. Is that clear, guys? Guys?
Yes po.
Sir.
Okay. So now let's talk about absolute value. Let's recall. There are limits na involving absolute value, no? So for those limits involving absolute value, kung natatandaan nyo, anong definition natin ng absolute value, guys? Anong definition natin ng absolute value, guys? Absolute value function. If I have, let's say, f of x, and that is equal to absolute value ng x. This is equal to what? It is defined by two expressions, no? So the first one is x. If x is what?
If x is greater than 0 po.
If x is greater than 0, no? So if x is greater than 0 or equal to 0, yung equality here, pwedeng dito isama sa kabila kung gusto nyo. Pero normally dito natin siya sinasama sa positive x, hindi sa negative x, no? Yan. Okay? So that is how we define it. So example, if I have, let's say, absolute value ng x plus 3, how are we going to remove the absolute value and express it as a piecewise function? It is negate the inside negative x minus 3 if x is what? If x is less than negative 3. Kasi saan ba nagsisiro itong x plus 3? Neutral siya sa negative 3, no? Pag negative 3, magiging 0 yan. Okay, guys? Then just copy the inside if your x is to the right or equal to negative 3. Am I correct? Guys?
Yes po.
So, yan, no? So that is how to remove. Let's say, I know that x is close to 2. Let's say I have x approaching 2. If x is approaching 2, how can we simplify this absolute value? Halimbawa, meron akong x minus 7. This is equal to what? Since I know that x is close to 2, so if x is close to 2, so perhaps x is what? 1 to the left and at most 3 to the right, no? Ang pwede kong i-substitute. So pag sinubstitute ko yung mga value na close to 2, what happens to x minus 7? Is it positive or negative? Guys, actually pwede yung 2, no? Is it positive or negative, guys? Guys, negative ba yung loob or positive? Dahil negative ang loob, so ibig sabihin, I have to negate the what? X minus 7. So I can have it negative x plus 7. So I can simplify this without absolute value into negative x plus 7. Okay, guys? Guys, let's say I have x approaches negative 3. Oh, what can I say about 2x minus 3? What's the absolute value? Can I say 2x minus 3, guys? Guys? Yes, no? Because if x is close to negative 3 and substitute it here, no, it's not. Let's say it is, it's not, no? Let me revise.
Hindi po.
Oo. I want it to be 2x minus plus 9. What about that? Can I copy 2x plus 9? Can I just copy 2x plus 9? Di ba pag
Yes
x
po.
is negative 3 or close to negative 3, this is always positive, no? Okay? So I can just simply write it 2x plus 9. Is that clear, guys? Guys?
Yes po, sir.
Okay. What about greatest integer function? Kasi yung after nito, pag na-discuss ko na to, hindi ko na kayo tuturuan ng other examples kasi I prepared already videos that you can watch and then go over with those. Ang daming examples na ginawa ko doon. Is that clear, guys? You just watch them. Okay, greatest integer function. Okay, so let's recall this greatest integer function. Pag sinabing greatest integer function, so it is given by this, f of x is equal to, and this is the notation, pero iba-ibang book, iba-iba yung notation ha. May mga book, hindi ganito yung notation. So merong ganito lang, something like this. Meron pa akong nakita, ganito. Yan. Okay? May number dyan halimbawa. So depende sa book na ginagamit. Pero normally, ito yung gamitin. O kaya ito sa mga discrete math. Yan. How do we define this? Greatest integer function is a function that produces always an integer value, no? Either positive, negative, or zero. So depende kung nasang interval ng x kino-consider. Okay? At dependent siya sa interval. May interval, kung minsan mahaba, kung minsan maikli, and then kalimitan, one ang gap, no? Ng interval na yun from end to end. So, ang value ng lagi niya, ng function, laging an integer. Whatever x you input on the interval na normally short interval, okay? Between two integers you input. So, the value is always an integer. Ang input kahit na ano, pero ang output laging integer. Okay, guys? Actually, is equal to n. Yan. Where n is less than or equal to x, but x is less than n plus 1. N is an integer. N is an integer. Paki-check nga kung tama guys yung definition ko. Guys. Nasa na ba yung ating mga salutatorian dito? Guys, is my definition correct, guys? Guys, naku, hindi makausap ang mga bata. Guys.
Yes po.
Ha? Okay na yan? So, I'm looking for an example. May magandang example here. Okay, so this means integer ha. So kung ang in-input ko halimbawa sa value ng x ay 2.5. So 2.5 ang x. Ano yung integer na nasa pagitan ng dalawang integer? So ano yung 2.5 na nasa pagitan ng dalawang integers na magkasunod? 2 and what? 2 and 3. Pero ang x daw ay equal sa, ang greatest integer ay equal saan? Sa n. So, equal siya sa 2. Okay? Kaya 2.5 equals sa 2. Kung itong in-enter nyo, equal pa rin sa 2. Is that clear, guys? So, ano ang greatest integer ng, let's say, 2.5? So that is equal to 2.
2 po.
Yung greatest integer ng negative 2.5, guys? Guys, anong greatest
Negative
integer
3.
ng negative 2.5? You are pulling it to the left. Always pull it to the left.
Negative 3 po.
Negative 3. Pag kayo nalilito, ang gawin nyo, you draw it on a number line. So, ito yung, let's say, 2.5, yan. 2.5. So, ito yung dalawang integers, 3 and 2. Lagi hinihila siya pakaliwa. So, magiging 2. Okay? So, if I have, let's say, 0.8, anong sagot, guys? It is equal to
0
0.
po. Opo.
Okay? Now, how to simplify greatest integer if you know at least yung value ng x, no? Let's say I have x close to 0 from the right. So, how am I going to remove the greatest integer here? Symbol. Let's say I have here greatest integer of x. How can I simplify this? So, ano ba yung nasa right ng 0, guys? 0.01, 0.01, 0.1. Basta huwag masyadong malayo, ha? Kung linear, okay lang na medyo 0.5. Pero pag naka-square kasi yung x, pag medyo nilayo mo, hindi mo makikita yung behavior, lalampas ka ng kanyang parang neighborhood niya, no? So, we have, ano yung mga sample? 0.01, 0.001. So, saan siya pupunta? Guys, anong value niya? Guys, ang value ko, nasa right. Pero saan siya pupunta? Hihilahin siyang
Papunta 0 po.
0. Okay? If I have, let's say, x approaches, let's say, this is not limit, ha? Sinisimplify lang natin yung what? Yung symbol na to. So that we can easily evaluate limit, for instance, na? Yan. Let's say I have greatest integer ng x minus 3. Again, meron tayong 0, pero galing tayo sa what? Ito yung negative 1, galing tayo sa kaliwa ng 0. So pag ito nabawasan ng 0, ay yung 0 nabawasan ng konti, mapupunta siya saan? Dito, no? Sa kaliwa ng 0, right? Ano yung mga
Yes,
sample noon?
Negative 0.5.
Oo. Kaya ito, parang nadadagdagan to ng negative something. So magiging negative 3 point something. Okay? So anong simplified form nito? Negative 3 point something magiging?
Negative 4 po.
Negative 4. Ito yung sa x, ha? Pero yung x minus 3, mapupunta sa negative 4. So ibig sabihin, kapag ang x natin is between negative 4 and negative 3, kapag ang x natin ay between negative 1 and 0, yan ang x natin, right? Yan. So meaning, paraslim to, kapag ang x minus 3 natin ay element ng negative 4 to negative 3. Ay, bakit nabakod ko itong isa? Naduduling na ako. Yan. Kasi to the left eh. Negative 3. Yan. Okay? Kapag ang value daw ng x minus 3 nasa pagitan ng negative 4 to less than negative 3. So, laging ito ay what? Negative 4. Okay, guys? Guys.